Good evening, everyone. It's give me immense pleasure to introduce our today's distinguished resource person, Dr. Ram Surendra Singh, sir. Dr. Singh is a mathematics facilitator at Sanjay Guwahati International School, Kolhapur, Maharashtra, where he has been playing a key role in nurturing young mathematical minds with clarity, rigor, and passion. His interest Area of interest is abstract algebra, a subject that forms the foundation of many advanced areas of mathematics, including number theory, cryptography, and mathematical structure explored in higher studies. Dr. Singh is known for his clear teaching style, strong conceptual focus, and his ability to connect abstract concepts with innovative understanding, making him an excellent guide for students preparing for competitive exams such as IIT JAM. We are truly honored to have him with us today as part of our online IIT JAM lecture series organized by the Department of Mathematics, Wilson College, Autonomous Mumbai. On the behalf of our department faculty member and our participant, I extend a warm welcome to Dr. Ram Singh, sir. You can
Yes.
continue, sir. Thank you
Thank you,
so
ma'am, for
much.
the wonderful introduction. So, dear aspirants, so today we will just practice the questions. I have sent in a group the link of all the questions from the last 10 years. I have added more also. So till now, 2000 from 2012 to 2015, 2025 means last 13 years questions from the group theory. I have accumulated in one PDF, and the solution also I'm preparing separately. Maybe before next class or after the last lecture, you will get all the solutions also. So today class will be, I will put the question here, we will discuss and then we will arrive to the solution. And I request everyone, please be present mindfully also, and you can unmute, or every time you can unmute. It is also okay if the sound is not coming outside. Otherwise, whenever you want to speak, just unmute and speak directly. Okay. So let's go ahead. So this question number 31 to 40, whenever the number is here, we will see the other options also. It is MSQ type questions. Okay. From 2015, the questions in 2015 exam, if you see, the questions are numbering are different. It is 1 to 30. Then again, MSQ starts from 1. Correct? In 2015 till 2015. 14, 13, 13, 12, it is descriptive questions more. So you will find very less objective question I put here in 12, 13 questions. Okay, so let's go ahead. Is it clear? You can unmute and give the your input while solving the question. So now I'm starting from 2020 questions, 2020 till 2025. Some of the question from 24, 25 we also attempted already. Hmm? So let's see till where we can attempt different type of question. So consider the following group under matrix multiplication, where H is this group upper triangular matrix and PQR is from real numbers. Okay. Now then the center of group is isomorphic too. Yes, friends, you can unmute and now discuss. Or tell me the procedure, like what first thing I should do.
First, we will find the center of the group. That will be the
Where
identity method.
center of the group.
Yes,
How
sir.
we can
So
find
the
the center of
element,
the group?
so those elements that commute with every element with the group.
So how I can write? What is the center of group definition? AB equal to BA, right? Like for all A and B belongs to G, correct?
Yes, sir.
So I will write one here. The elements are matrix, correct? So I will write 1 PQ 0 1 R 0 0 1. This is my one matrix. Another matrix I can write here, suppose 1. I will write ABC. A, B, 0, 1, C, 0, 0, 1. This is my true matrix. Correct?
Yes,
Suppose
sir.
A and B matrix. Now I have to check AB equal to BA. Can anyone please calculate fast AB and BA?
Sir, I have calculated AB.
Huh. Tell me
It's
entry 1
1
A
uh,
plus P.
A plus B,
Huh?
then B plus Q plus uh, B
B
into
plus
B plus B
PC.
plus Q. Yes.
B plus PC plus Q. Correct?
Hmm.
B plus
Then
PC plus Q. Next entry
then 0,
0
1,
1
and uh, R plus C.
R plus C. Very good. Next
Then 0,
0
0, 1,
0
0, 1.
1. And what is
This is
BA?
give some time.
Okay. Everyone, please do. This is matrix multiplication. All 12 aspirants.
Sir,
Hmm.
1
1
P plus A,
P plus A. Very good.
Q plus AR
Q
plus
plus
B
A. Q plus AR
plus B.
plus B. Okay. So I will write here
Next,
Q plus AR plus B. Correct. Now can you tell me just A, 2, 3 entry?
0, 1,
Huh?
0,
0, 1. And what
R
is
plus
A,
C.
2, 3 entry? R plus C. Okay, done. So and
Next,
last is
0,
0, 0, 1.
0,
Correct?
1. Yes, sir. Yes, sir.
So to make this AB and this is BA, if I write here BA and AB, this should be equal. It means all entries should be equal. Matrices are equal if the all entries are equal. So here all entries are equal except this A13 entry. So that I can write here. I'm writing that I want B plus PC plus Q should be equal to Q plus AR plus B, correct?
Mm. Yes, sir.
I want this entry, this entry, and this entry should be equal. So here I can say that yes, QQ cancel. So I should want here B plus PC, even Q plus B. I can take PC equal to AR, correct?
Yes, sir.
So I want PC equal to AR. It means what? When it will be equal, then PC equal to AR. Hmm?
P and R should be equal to 0. Okay.
P and R should be equal to
0.
0, correct? This will be equal when both it is 0 equal to 0. How? Why? Like you, we are forcing to say that P and R is 0. Why? Hmm?
Mm. So if we choose any other values of P and R, like if
Hmm.
we take P is equal to 1 and suppose R is equal to 1, then
Hmm.
A is not equal to C. We
A
will
is not
have
equal to?
A is equal to C, which is not possible here since A and C are distinct real numbers.
Distinct real number, correct.
So we need to make them
It is not
equal.
mentioned here distinct.
Oh,
2 into 3 equal to 6 into 1 also.
hmm,
Both case it will be possible, correct?
yes, sir.
Hmm? So why you were saying that P and A should be 0? What condition makes us? Anyone else? Hmm? Hello? Okay. So here the condition like we will make as an open discussion again for this, that when P equal to AR, then we will say that AB is equal to AC, correct? When PC equal to AR, then we will say that AB is equal to AC. So we all those number only will be in a H group, right? So here the condition what one student said that I want to take like P and R should be 0. Okay, so why it is making so? Maybe you know the solution, I don't know. The condition is still it is like open discussion till now. Okay, this is open discussion now. So yes, we will take like this P and R should be 0. So once suppose if P and R is 0, this whole condition is 0. So the matrix inside H, the inside the center, it is nothing but 1 0 Q 0 1 0 and 0 0 1. Only this type of matrix will be here. Correct, in center of the group, under the assumption that P and R should be 0 or A and C should be 0. Correct. If P and R is 0, this means the other matrix we are considering in the same format. Correct. So now suppose we have written 1 0 Q 0 1 0 and 0 0 1 under the assumption that P and R is 0. Now we know this type of matrix is in H. Then which option will be true? Hmm? How many choices we have for Q?
Set up all real numbers.
It is all real numbers.
Hmm.
Correct. So Q is this is all real number, right?
So option B, I think, R comma plus should be the
Option
option B.
option B. So this is all real number under addition. It is isomorphic to that. Will not remove zero also. So it is isomorphic to real numbers. Again, in this question, one is open discussion. Why we have to choose that this is equal to 0? That is correct. We have to choose it is equal to 0. Next question. Here. Let S1 Z belongs to complex mod Z equal to 1. What does it mean? What is this?
It is a
This is
circle of
circle,
radius 1 in organ plane.
Argand plane, and center is origin.
Yeah.
If I write mod z minus 2 equal to 1, it means the center is 0, 2, 0 and radius 1. Correct. Be a circle under group multiplication, then the set theta. So I want theta in real number such that e raised to I 2 pi theta is infinite. It should be infinite. Correct? So if I take theta is 0, suppose, because theta is a real number, so I can take theta 0. If theta is 0, then what will be this set e raised to I 2 pi theta?
It is
e to the power
1.
0, 1.
It is just
1.
1, correct? So this is not infinite for theta is 0. It means that 0 does not belongs to this set, correct? So 0 is not in set. Similarly, if we take any number, you tell me one number theta where this e raised to e I 2 pi theta is infinite.
It will never infinite because it is cos and sine when it is periodic function, so bounded.
Huh? It is never infinite. I want that type of theta.
So option A will be correct. It will be empty.
We can discuss. Okay, empty. I am thinking like suppose theta is rational number. Suppose 2 by 3. I have given one example. If when theta is 0, so it is only one element. Correct, in this set. If I take theta is 2, then how many element will be here? It is generator, no? It is saying it is generator group. Suppose theta is 2. So it is e raised to I 2 pi 2. So it is e raised to 4 pi. Correct? Yes or no?
Mm. Yes, sir.
So next number will be under multiplication if I take. So next number will be e raised to I 8 pi. Correct? Square.
Sir, here I am in doubt that theta belongs to real number. This is set and this notation is open bracket e to the power 2 pi theta. It is infinite. We consider it is group or it is generator or it is a set. Here option are things set.
It is set. It is a generator. It is
How is
generating
the
this set.
element? I mean, if we take suppose theta is equal to particular, when we take particular value, then it is 2 pi theta. It is something, whether it is rational or integer, it has must finite number of values. Okay.
No, why it must finite values? If I take theta root 2, then
Theta root 2, then 2 pi root 2. It is under the formula, the cos 2 pi theta plus I sin 2 pi theta, and cos and sin both are bounded.
correct.
Whatever the domain, because sin and cos all are taking those rational, irrational, whole real number are taking. They are taking.
Yes, yes. So here we are considering that is theta value all real numbers, right? So when I give example 0, so it was 1. And what is this set? It is considering all those theta where e raised to I 2 pi theta, the set generator is infinite.
So
So
that
I am
means
thinking in
it's
this way.
so that means the order of e to the power I 2 pi theta is infinity, right? The
Means it is not coming that generator. If you go on multiplying the same number, it will
mm,
never give you the identity.
Hmm.
So I think we have to find a such type theta that give a infinite.
Infinite. The set is infinite. Like for example, in Z, if I write 1, then I can take 1 plus 1 plus 1 plus so on. It is going to infinity. So that set is infinite in Z. Correct? Here,
Hmm.
I am writing number. Suppose the fixed theta is 2 now. If theta is 2, so it is e raised to I 4 pi. Correct? Now my first element will be e raised to I 4 pi. Second element will be I will multiply it with e raised to I 4 pi. Again, it is this number. So what I will get here? E raised to multiply same number with this. So what I will get? I square, no?
Hmm.
It is multiply, it is addition. So how much I will get here?
E to the power I 8 pi.
E to the power I 8 pi. Correct? So if you do this thing, multiplication, so somehow the multiplicative identity is 1. I will end up to 1. Maybe e raised to I 4 pi is only 1. We can check. It is cos 4 pi plus I sine 4 pi. Correct?
Hmm. Yes, it is equal to 1.
So here only I am getting equal to 1. So only this is the identity element only I am taking. If I take 2 here, okay, it is I. E raised to I pi if I take, then what I will get? E raised to I pi suppose. Just. Theta is 1. Theta is
Okay.
1 by 2. If theta is 1 by 2, so it is e raised to I pi. So for that it is cos pi plus I sine pi.
-1.
So it is -1. Then I will multiply again with the same number to the same number, correct?
Hmm.
So it is
Yes,
e
sir.
raised to I 2 pi I. So if it is e raised to 2 pi I, then I will get 1. So here for theta equal to half, I am getting 2 element here. In this set, e raised to I 2 pi theta. So in this case, for any rational number, if you put theta, and if you go on doing, it will end up somewhere. Correct?
Hmm. Yes, sir.
Because whenever you put theta some rational number, this 2 pi, it will get cancelled, and here you will have some cos thing, and it will give you 1. But when you put irrational number, theta irrational number, if you put, I think it will be go to infinity. Okay? You got my point? It is nth root of in unity, it will be there when theta is rational. So somehow it will stop. When it is irrational, it will go on.
Hmm. Yes, sir.
Suppose I take root 2 only theta. Then till what you will do addition, addition, so that you will get 1. So you will not get. This is my thinking. So if you think in this way, so which answer I should mark?
Since set of irrational numbers is uncountable, so option D, I think.
Option D, right? Irrational number. So it is uncountable. Okay?
Sir, how it is goes infinite? If we take theta is equal to root 2,
Huh.
then it is a termer getting multiplied. That is why it is generated. Okay, uh,
Yes.
this will become 2k to I 2 pi root 2 plus root 2 plus root 2 up sometimes n root 2. Okay, and depending on the n, it will vary.
Hmm.
Okay.
So at what time it will become 1? So it is goes on, goes on, goes on. Yes, no?
Yeah. Yes.
Huh. Good discussion we had. And I am telling here again that it is not like I am saying then it will be correct also. Huh? We can verify and you can counter also. Hmm? Because the solution we don't have here. And marking scheme answer key we can check. But what happened? The downloaded answer key and the downloaded this may be match. Some sets are also maybe different. So question number, we have to be very much sure that it is correct. So I hope here what we understood, that it is infinite set when theta is irrational. So what you said, if I take cos I 2 pi root 2, then plus, it is not I, it is just cos I sine 2 pi root 2. So for which value it is becoming 1 if I take multiply these things. Correct? So e raised to 2 pi root 2 raised to n. I want here 1. Correct? So for which value it is becoming 1? So it is not happening here. But when we take here some rational number p by q, so it you will find out the value of n there. We can adjust. Okay? Yes?
Yes.
Okay. Now this question. Let f w belongs to complex number and omega belongs to complex number. Omega raised to 2020 is 1. So how many elements will be there in the f then? Hmm? It is mixed complex with the group theory, but okay. If I cube is z cube is identity, so how many complex number will satisfy that condition?
3.
3. Now here the z raised to 2020 is 1. So how many complex number will be there?
20.
2020. So f, cardinality of f is 2020. Now we have G group. It is upper triangular matrix. Omega and Z. Z is any complex number, but omega belongs to F. It means that if you uh, multiply some element here, that order is 2020. Correct? You will raise to 2020 times, you will get identity elements 1. And H is upper triangular matrix, 1, 1 on the diagonal, and Z is here upper triangle. Now then the number of coset of H in G. Okay. So number of coset is H by G, the order. They are already asking number of coset. It means H is normal, right? So we have to calculate this thing. Okay. H GH index. So what is order of GH index here? Hmm?
Order of G by order of H, if it is 5. Yeah. Order of
But both
given
are
order of
infinite, no here. Both are
yes,
infinite.
yes, yes. That is why it is not working in this formula.
Both are, so that's why I've not written order of G by H. Okay, correct. But number of cosets. So what is happening? The H is uh, absorbing in the G. Correct? H will absorb in G. Correct? It is absorbed. If some elements is there which is in G, we can say that here this Z, the coordinate is here. Only the extra element will be there in the coset. It will be element from the F. Yes or no? That every element in G by H, I can say that it the element here, suppose G1 or that group plus it will be like H form. Correct?
Sir, I
But
think
this
G plus H, if the element are coming from H, then it will become only H. Okay, that is the
only H.
identity of the
Correct.
quotient group.
Yes,
So
very good.
we have to consider the element which are coming from the outside of the H, and they
Huh.
will make the distinct
Distinct,
quotient.
correct. So that outside from the H, so how many elements are coming out from outside from the H? Only that G. That is the W.
2019.
No, that is the W only, no? Cardinality of G only. Cardinality of
That
F.
Yeah.
2020.
So it is 2020.
Hmm.
Correct?
Yes, sir.
Yeah, so it is 2020. Whatever element is there, it will absorb in H, the H elements. The rest is only which is outside this. So how many W's are, that is the order here, that is 2020 only. The element from F only. Correct?
Yes, sir.
Hello? Okay.
So did this question came in 2020? So the question that we solved, did it appeared in 2020 IT jam exam?
2020
yes.
IT jam exam.
Okay.
Yes, all the questions which we have done, it is from 2020 exam till now. It is question number 30. So I in a link which I have shared, no, there is all question paper. So in that question paper, you can see that question number 30 in 2020 exam, it is this question. Okay. Now this one. Let G be a group with identity E. H abelian group, non-trivial, and it is proper subgroup of G with the property that H intersection G H G inverse is identity. So only identity element are there. Common, nothing else. Now the more information is given that K is G belongs to G, GH equal to HG. So this type is called what? Centralizer type, right?
Yes, sir.
GH equal to HG for all H belongs to H. Then K is proper subgroup of G, H is proper subgroup of K, or K equal to H, or no abelian subgroup exists L subset of G such that K is proper subgroup of L. Okay. Now, which is trivial here? H is subset of K or K is subset of H?
Sir, H, uh,
H is what? Abelian, right? If H is abelian, then
Sir,
any two element in H is commute.
intersection is subset of K.
Huh?
H intersection G inverse is subset of K.
A. H. H intersection G in GH inverse is identity only. So it is always subset of all groups.
And you are asking H or G, H G
H and
inverse
K.
only.
H is subgroup of G. That is no problem.
Yeah.
It is always there. K is also subgroup of G. No problem. But inside H and K, I am asking. Which is H is bigger or K is bigger? Or we cannot say anything. I will put charging. So as H is abelian group, any element in H will commute, right?
Yes,
Yes.
yes.
So I can take element from H. If I take element from H, so here I can say that K, what is K? K is all those elements from G such that GH equal to HG for all H belongs to H. So
And
instead of
H is a
taking from
subset
G,
of K.
huh?
H is a subset of K
Very good.
because
Yes.
here all element of G, all element coming from G including H in K, and H is abelian means only the
Yes.
entire element into the H only commute themselves.
Correct.
Here outside H also commute of H element.
Correct. So K may have more element than H. Correct.
Yes, sir.
So till now we have figured it out like H is subset of K. So either the B can be true and C can be true. Correct. Now, can we take, if it is proper subgroup, so we have to show that some element is K but it is not in H. Correct? So take some element from K, that is small k. This is in K, but this small k does not in H. Correct?
Yes.
It means that K H is equal to HK for all H belongs to H. Correct?
Yes.
Yes, sir.
Huh. It means that now we have taken here KH is equal to HK for all H belongs to H, and K does not belongs to H. Correct? Now we will use this condition H intersection GH G inverse. Correct? So K is also in G also. So for all G does not belongs to H, it means for all K does not belongs to H, GH H intersection GH inverse should be identity. Correct? So what I am getting here from this, that this K I can write here H K H inverse, and this H is belongs to G also. Correct?
Yes, sir.
1 minute. Here I am changing for all not H, for some H. It is for some H, it is true. I am removing this. For some H, KH equal to HK. So it means that I can write here that H is equal to K inverse, or this side H I can write. I can write H K H inverse. Correct? Where K belongs to G. So what I have done, I have taken some K belongs to K such that K is not in H. If K is not in H and K in K, so any element in K can be written as some multiple of element of H. So it is KH equal to HK. Then I can write the left hand side H in this way, that KH K inverse. Is it clear till now?
Yes, sir.
Yes. And now K is in G. It means that H belongs to GH G inverse. Yes.
Yes, sir.
Now H belongs to GH G inverse, and H is also in H. So this is the element H which is common in both. But condition is given that this intersection is identity. So our assumption was wrong. What we have taken, that there exists some element in K which is not in H. So our assumption was wrong. So every element in K will belongs to H because of the first condition.
Then K will
Clear?
be subset of H.
So K will be also subset of H. If both is subset of each other, then option
They
C
are
is correct.
equal.
They are equal. Correct? Okay? Hmm. Now this question. S3 to S1. S3 is set of all permutation with 3 elements. Is it clear the previous one question?
Sir, I didn't get how we came to the conclusion that that small k belongs to H.
Yes. We have not we have proved in contradiction way. So suppose I am taking one element from capital K, correct?
Yes.
Which is not in H, suppose.
Okay.
So any element in K can be written as some element in H multiple.
Okay.
So I can write KH equal to HK for some H belongs to H, correct?
Yes.
Then from right hand side I have H and K, this circle. I can take K that side, or I can say that post multiplying by K inverse on both sides.
Okay.
So this will become KHK inverse here, and this will just become H.
Okay.
Now this K is in capital K, it means that this K is in G also.
Okay. Okay.
So this H equals to this element, it means H belongs to GHG inverse,
Okay.
correct? And H is
Yes.
also belongs to H,
Yes.
because this H was for some H. Now intersection, it means H belongs to GHG inverse, intersection H.
Then G is H is identity.
But H is identity, it should be identity, it is contradiction. Because I have taken H, H should be identity, right?
Yes.
But it is contradiction.
Because H shouldn't be identity.
H is not an identity. It is always true K equal to K, no then.
Okay. Okay. Okay.
So for some element, it is true non-identity. It is given that the intersection is only identity.
Okay.
So we are getting some more element in the intersection. It means what I have assumed that K does not belongs to H was wrong.
Okay, sir. Like we have to take that H for all H in H, right? Like KH equal to HK for all H in H. That's a definition of K,
Yes.
right?
KH is equal to HK for all H in H. Yes.
Yeah. Now we have gotten that H is only identity, but that is wrong
True
because we
for
want
all.
all
Correct.
H.
Correct.
Okay.
Yes. Hmm.
Okay, sir. Okay. Okay.
Yes, correct. I have to take for all H in
Sir,
H. It is
sir,
commuting. Yes. Okay.
here can we think as K is the normalizer of the subgroup H, because normalizer means
Yes.
yeah, so here H is the abelian it is given, okay.
Hmm.
That is why its normalizer coincide with itself set.
Yes.
I think
Correct. It
then
is normalizer of H or centralizer of H. What do we say? Hmm. Normalizer. What is the definition of normalizer of set? Normalizer of element?
uh, uh, it is a collection of those elements which in which the given group is normal,
Hmm.
behave as a normal subgroup. It is the
Yes.
smallest collection of normal normal. I think what is can I say? It is the smallest normal subgroup containing those these set.
Hmm. Yes. So here, this K is nothing but GH capital G inverse. G capital H G inverse. Correct.
Yes.
Here, the K in our case, it is GHG inverse, right?
I didn't get it, sir. How come K is GHG inverse?
Like we are taking all these element now here. No, it is not taking all element. Only H means which is commute. Here it is like GH equal to HG.
Yes.
So here like left, we can say like G capital H, all H, and H small g. It is for all H. Correct, no?
Yes, yes.
Yes. Small h. Correct. Okay. So I have taken this proof method. Other tricks are, other rules are also there. We can apply anything. And I have prepared handwritten notes. It is there. I will make it type all the results of the group theory. Okay. Tricks. So is it clear now? This question number 40, 2020?
Yeah.
Yes, sir.
Yes.
Okay. Now 50, 20 question. S3 set of all permutation of three elements. S1. What is the S1 here? Hmm? What is S raised to 1?
It is the group of the complex number which are satisfying mod z equal to 1.
Mod z equals to 1.
Yeah.
Okay. Then what is the question they are asking? Non-injective group homomorphism it is. So the number of elements in the kernel of phi. So what is the thing we know about the kernel?
It is a normal
It is
subgroup.
normal group. So
Here
normal group of domain. So what is the normal group here? Only a identity
A3 and
A3 and
S3. S3.
S3. Correct?
yes,
And it is a non-trivial. Non-trivial means all will
A3.
not goes to identity. Correct?
Mm.
Phi not equal to identity.
So it is non-trivial. Non-trivial means it is not like trivial, like all S3 element will map to identity. No, it is gone. So if it is non-trivial, then S3, this is the not possible for the kernel field. It is non-injective also. So this is also not true. Correct?
Yes, sir.
If it is injective, then 1, 1, 1, 1, 1, 1, 1. So kernel is identity. Now, number of elements in the kernel of E. So how many elements are there in A3?
See,
3.
3 elements. So this is this. Clear?
yeah.
Okay. Now, suppose G is a group of order 57, which is not a cyclic. Okay. So it can be decomposed, not abelian definitely, but can it be isomorphic to some non-abelian group? Non-cyclic means non-abelian. Now, if G contains a unique subgroup of order 19, because it is 19 and 3, then for any G does not belongs to H, the order of G will be how much? Hmm? So if it is unique subgroup of order 19 G has, it means that the element of the group order 19 is normal in G, correct? Hello?
Yes, say one again. If it is a contain unique subgroup of H of order unique subgroup, it is by Syllo's theorem, it should be normal.
Correct. So it is
And
normal, right?
yeah,
So if it is normal, then we can define like G by H type of things, correct?
yes.
So the element which is not in H, so what will be its order then? I think in this way that if I have G by H,
Then it's order 3, I think.
order 3, correct? Because then it will generate the coset of element which is not in H.
Yeah.
So that order will be the 3 only, correct?
Hmm.
Very good. It is easy type of questions. So now till now we completed all the questions which asked in 2020 exams. So,
Yes, yes, it is from 2020.
so it is completed 7-8 questions we have done.
Yeah.
Now 2021. So what we have done till now, see the concept here in this paper, it was isomorphism which is used. The kernel phi, how many elements are there? Mostly the normal groups, center groups, center of group. The first question ZG multiplication thing, and one is again the open question like how it is like if it is equal some PQ equal to RQ, then why it is 0. Correct. So that we have to see. So main concept here was if you see, even though we know the definitions, every day we have to apply so much of our mind to get into the questions. Clear? Not directly the formula here we have used. Only kernel phi there we use G by H and other things. Hmm? More or concept type in 2020. Now in 2021, the first question if we see, we can apply the formula directly and we can get the answer. So please attempt this. I want answer here. Please do this. How many elements of the group Z50F order 10?
So 4.
Which thing you applied here?
Euler's Torossian function.
Euler function, phi of 10. So it is 2 into 5. So it is 1
Hmm.
into 4, correct?
Hmm.
Phi of 2 into phi of back. Very good. Because phi of P is P minus 1. Sabas. So it is 4. Very good. So now here directly formula. Whenever we have the number of element, we can use. Correct. Now next thing. It is again conceptual. The group Q plus has no proper subgroup of finite index. Is this statement is true or false?
Sir, I think it is Q plus, it is group under addition. Okay.
Hmm.
Uh, for let if possible, I think there is a proper subgroup which is of a finite index. Okay. Then Q by
Hmm.
H is equal to something finite. Okay. That means
Correct.
there are distinct coset, left or right coset of uh, that subgroup in Q are finite,
Hmm.
and if we take union of those collection of cosets, we will get whole Q.
Hmm. Correct.
I think this is not possible because we cannot finitely generated Q.
Correct. Very good. Actually, Q is a field. Huh?
Yes.
Field भी है, ठीक है. But here it is like the if you have any proper subgroup of finite index, you are correct. Then it should have some finite here. Correct.
Yes.
Not order means this. Yeah, this should be the finite. If the index is finite, so you are correct. Like when you take the union, it is not possible. It is not the final. It is not a finitely generated. So that's why the statement one is true actually that it has no proper subgroup of finite index. Clear?
Yes, sir.
Now the second, the group complex number minus 0. So we have to remove the complex number. We have to remove 0 from complex number with multiplication has no proper subgroup of finite index. Hmm? It has or no?
The thinking.
Okay, think. It is in multiplication, no? In question group addition, we can add on multiply. We can add the element, but we'll never get the additive identity 0. Okay, think. We have seen in the starting only when I write complex number, suppose 2 pi I or just I suppose. This is a complex number, right?
Yes.
So it has order 4.
Yeah.
Hmm. And e raised to 2 pi I n. It has some finite order. In complex number, in a question group, we don't have a element of finite order, but here we have the element of finite order. Hmm? Complex number raised to n. Correct. We have this solution, no? Z raised to n
Yes.
equal to 1. So it has all the elements. Like we can take the modulus is equal to 1. So with this index, it has the finite index. Correct?
Yes.
Hmm.
Yes.
So which one of the following statement is true? So first is true and second is false. It has a proper subgroup which has a finite index. So here we can say first is true but second is false.
Sir, please explain one again, second option, because we are taking those z to the power n equal to 1. Okay, this is a subgroup of under multiplication of C. Okay, and
Hmm.
this is a element of something n. If we quotient C by suppose this is group, I say H, is
Hmm.
the group of the nth root of complex unity. Ah, so it is C by H is equal to finite index.
Hmm.
How? And
Hello.
hello, sir.
Hmm.
How it is finite?
Finite index. We can create a homomorphism here.
Yes, C2, uh, C2, C by H. Okay.
We can create here homomorphism and we can see that what will the index here? Maybe the index will be 2. S1 has infinite but non-trivial index. So however, like we can say there is a proper finite index. Set of all nth power has index n. So here when we say here the index is 1, all complex numbers. Okay, you are correct. Like your question is, sir, can we take like G by all suppose H whose nth power is equal to 1, correct? Hello.
Yes, sir.
Yeah. So how this index is finite? So I am saying whenever we take all this complex number H whose Z raised to n is equal to 1, suppose H is equal to Z raised to n, n belongs to natural n, this has the index n. So this index n is finite here. If we take Z square equal to 1, so uh, then we will have here this number Z square equal to 1 means it is 1 and minus 1. How many element will be there in Z square equal to 1?
2.
Not 2. How here? It is complex number, no? Two solutions will be there. Correct. That is the two solutions. So nth root of unity when we take G by H, then its index is n. So how it is that we have to prove? Okay, so that is now again it's like proof question. Can we prove that the index of G by nth root of complex number, the index is n? Clear?
Yes, I'm trying.
Set of all nth power. This we can remember that complex number with set of all nth root of unity, the index is 1. Index is n. So this is finite index here. Okay. So now the rest of the questions from question 2020 from 2021 exams. So you can see that all questions I have combined here, and till the last 26 page. So it has more than 120 problems, or more than that all also. In every year we have 8 to 10 problems. So last was question number 9, 2012. So till 2012 I have combined here. I will try to make the solutions and the results which is used in this questions, and I will put in the that site. Okay. Now what I am requesting that I will try problems. You also try this problem after this. Okay. After this, from till where we have done. Yes, we have done till here. So question 20, 20, 21. After this, at least 15 problem or 20 problem. Okay. So this 20 problem, it is your homework for your next class, or we can fix that not 20 till 2025. Till 2025, all questions you try. It means then we will solve from last 5 years. And 25 and 24 question we have already discussed previously also, so it will be not a big deal for you. And even though like we have to means anyhow we have to write an exam, so we have to solve all questions, correct? So to make the class fast, and maybe it will be the last class next time, you solve till 2025 questions, and we will discuss that which you have solved, and we will discuss the result which you have done. So suppose I am using some result, you are using some other result. So we can discuss that result. Clear?
Okay, sir.
Yes, yes, sir.
Okay,
So
sir.
this is the homework. Homework means this is homework. So you have to try the all questions till 2025 and we can discuss then. Otherwise, like I am solving, you are solving, you can say that, sir, this 2021 we have already done. Go ahead. Or sir, I have got this option, but I am not clear in this thing. So we can discuss that thing. Clear?
Yes, sir.
Yes, sir.
Okay. And one test of whatever we have done till now, similar type of questions, I will put as an assessment. But this time the questions will be not a preliminary. The questions will be from exam type questions. Maybe not from previous years, but also the level of the
Yes,
difficulty will be
yes,
the
sir.
same.
Leave some assignment for us on thinking along with this. Especially, sir, I have been travel from dihedral group and related homomorphism. This type of problem I'm
Yes,
facing
yes,
कितने में देने का
with.
आपको?
yes.
Huh?
So the more problem we will solve, the more thing we can
Yes,
come
sir.
across the
Could
questions.
you reference once for where I can this type of problem
तुमने
counting
सैनिटाइजर कितना दिया
homomorphism
दीदी को?
uh,
अरे वो
counting
नेबुलाइजर?
homomorphism from
Madhvi
group.
ma'am, please mute yours. Yes.
I am saying, sir, where can I get some type of question based on dihedral group and symmetric group and counting homomorphism, non-trivial homomorphism, whether there exists some order of element. I think
Mm-hmm.
that is the little bit feel confusing to me during exam. It suddenly seems to be easy, but after some taking time, oh, that was not good. That was not
See,
correct.
now you, okay, so now you go through all the questions first. You just
Yes,
read
yes,
it. Till now, we have solved 3 years paper, 2021, 2020, on 24, 25 also in my previous
yes, sir.
classes.
Yes, sir.
There are less questions of the dihedral group, definitely. But
Hmm.
dihedral group questions comes like we can reject the options. It is one of the best counter
Yes,
example.
yes, sir. Yes, sir.
Correct? So it is one of the best counter example. So we can read the properties of that thing and then we can attempt the problems.
Sir,
So till
can I? Sir,
hmm, yes. So
can I? Today I am uh, trying to, one question from this group homomorphism type. It is. Can I say you the question because I am
yes, you can
not
put in
got
the
it.
group, no?
Yes, yes. I am putting in the group. Okay,
Hmm.
okay, sir.
So anytime any question is there, you can put in the group so that in the night time, if I have time, like in the night time, I will give the solutions. Or
Okay,
even if I
okay,
am not able, then the whole group, like peer group is there. You have 500 people in that group. Someone will
okay.
send. So make
Yes,
the
yes,
group
sir.
like active. Active.
Yes, yes, sir.
Hmm?
It was a question, sir. A group of order 36, and there is a subgroup H whose order is 4. Then there are some option are given whether is this subgroup H whose order is 4, it is abelian or it content in the center of the mother group of order 36, or it is the equal to the central center of the group,
It
something
is
like that.
abelian group because every
Yes,
group of order p square is abelian.
yes, yes. That
No, no,
was
but it is
also
not abelian. It is not abelian because it is 36, it is 6 square. It is 6
yes,
is not prime
yes. No, they are asking about the subgroup
of
H
order
whose
4.
order is 4. Is
That
it
group is always
abelian or
abelian.
is it contained in the center of the group or whether it is normal or not? Something like that.
Hmm. 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 Okay.
Okay, sir.
So this is always abelian. That is true. Correct.
Yes, sir.
Uh-huh. But next option, if the question is framing in front of us, then we can read every word, every given data, and then we can use.
Okay, I will
So now
put
you
in the
focus on
group.
means it depend upon you. But see the dihedral thing, you can use as a counter example. Now
Yes,
you
sir.
see all the questions from the last 5 years. See whether you can attempt up to the knowledge what you have. So while solving the question only, you will see that yes, I am not able to this type of question. Then read the concept which is required for that question and go ahead. So in this way, we will solve the problem also, and we can cover the concepts also. Okay. And if I find, I will make one assignment on just topic
Yes, sir.
wise,
Yes, sir.
and I will send. Okay.
Okay, sir.
Okay. Okay. Yes, ma'am.
I it's over, sir. It's done.
Yes, ma'am. Like now, yes, now we can
Okay, okay.
stop. And next time we'll meet. So I already given some homework so that if they also prepare, I will also prepared, and we can solve more problems.
Okay, okay, sir. Thank you so much, sir, for today's session. It was
Thank you,
very
ma'am.
engaging
Thank you.
and fruitful. Thank
Okay.
you, dear
Thank you, ma'am.
participants.
Thank you, ma'am, for organizing such helping hand. Okay.
Yeah, yeah.
Mm.
Thank you.
Thank you.
Thank
But
you.
one open question is there.
Yes,
Please
sir.
solve that. Okay. Mm.